Multiply or divide. Recall that when you have a whole number, there's an invisible 1 underneath. For multiplication, you're going to multiply all the tops together and all the bottoms together. 6 times 4 is 24. 24 times 10 is 240. 5 times 1 is 5. 5 times 1 is 5. Then you can ask yourself, how many times does 5 fit into 240? Well, 5 fits into 24 times, and 5 fits into 40 8 times. Depending on your teacher, you may be able to leave it as an improper fraction or as a reduced version of that. For dividing by fractions, remember we leave the first fraction, change it to multiplication, and flip the second fraction over. 8 times 1 is 8, and 9 times 3 is 27. That one cannot be changed into a whole number, and it also does not reduce. This is a digital lesson, so if you have the Great Minds platform open, you can follow along online, or you can follow along in the video. This says, make a right rectangular prism with exactly 48 cubes. So let's change the height. Let's make the height be 4. And let's just see what happens. Here I have a 2 by 4, which makes 8, and that's 4 tall, so that would be 8 on the bottom, 16, 24, 32, but I need to get to 48. So what if I made it bigger? Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 on the bottom. Let's see, 15, 30, 45, 60. That's too much. What if I did a 3 by 4? That would put 12 on the bottom. 12, 24, 36, 48. Yeah, that does work. 3 times 4 times 4 does make 48. How do you know that your right rectangular prism is made of exactly 48 cubes? The base had 12 cubes in the bottom row, and it was 4 rows high. 12 times 4 is 48. How many 1-inch cubes do you think pack a 1-foot cube? Explain. Let's watch this clip. So there are 12, and then 12, and 12 tall. Well, then the bottom has 12 times 12. That's 144 cubes in the bottom row. And then there are 12 of those rows. Well, 144 times 12 is 1,728 of those little cubes inside of a 1-foot cube. What is the actual number, and how close was your prediction? The actual number is 1,728 inch cubes that fit into a 1-foot cube. How close was your prediction? I did not expect this many to fit. But when I watched the video, I saw that there would be a lot. Now let's look at cubes with fractional edge lengths. How many cubes with an edge length of a half a unit pack into a unit cube? Well, we can fit 2 halves into a hole, and then there'd be 2 halves into a hole this way, and 2 halves into the hole tall. So 2 halves make a hole, 2 halves make a hole going this way, and 2 halves make a hole in the up and down direction. So there are 8 half unit cubes in 1 unit cubed. What is the volume of 1 cube with an edge length of half of a unit? Well, it is a half wide, a half long, and a half tall. 1 times 1 times 1 is 1, 2 times 2 is 4, and 4 times 2 is 8. This is 1/8 of a cubic unit. How many cubes with an edge of a third unit pack into a unit cube? Well, we should be able to fit 3 across, 3 wide, and 3 tall. So there are 27. It is a third wide, a third long, and a third tall. So 1 times 1 times 1 is 1. 3 times 3 is 9. 9 times 3 is 27. Each one of these is 1/27th of the whole. Each little cube in there is 1/27th. If we move them out, you can think of this one cube fills up 1/27th of the whole cube. Complete the table and look for patterns. So let's look at the edge length of 1/4. That is a fourth wide, a fourth tall, and a fourth long. 1 times 1 times 1 is 1. 4 times 4 is 16. And 16 times 4 is 64. These are a fifth long, a fifth wide, and a fifth tall. 1 times 1 times 1 is 1. 5 times 5 is 25. And 25 times 5 is 125. These would be a sixth long, a sixth wide, and a sixth tall. 1 times 1 times 1 is 1. 6 times 6 is 36. Then 36 times 6 is 216. Let's look at a right rectangular prism with fractional edge lengths. What is the edge length of the cube that you think best packs the right rectangular prism? Since the denominator is a 5, I'm going to use cubes that are 1/5 in size, because then I can use 4 here, 3 here, and 7 tall. It says, how many cubes with an edge length of 1/5 unit pack the right rectangular prism, and how do you know? Well, I have 4 wide, I can fit 3 across, and I can fit 1, 2, 3, 4, 5, 6, 7 tall. The base, the bottom, is a 4 by 3, so I can fit 12 into the bottom. And since there are 7 levels, 12 times 7 would tell me how many cubes in the entire prism, which is 84 cubes. Suppose 84 cubes with an edge length of 1/5 unit pack into the right rectangular prism. Suppose the volume of each cube is 1/125th of the volume of 1 unit cube. What is the volume of the right rectangular prism? Well, there are 84 cubes, and each cube has a volume of 1/125. Don't forget the whole numbers, we can put an invisible 1 beneath. 84 times 1 is 84, and 1 times 125 is 125. How did you find the volume of the right rectangular prism? I multiplied the number of cubes by the volume of each cube. Can you find the volume another way? Well, yeah. I could multiply 4/5 by 3/5, and then that would give me the bottom level. And then I could multiply that answer by 7/5 for the height. What is the edge length of one of the cube that you think best packs the right rectangular prism? Since the denominator is a 2, I would use 1/2. Complete the table with the lengths, widths, and height and volume of the right rectangular prism. The length is 11/2, the width is 5/2, and the height is 3/2. If we were to multiply, 11 times 5 is 55, and then 55 times 3 is going to be our numerator. Then our denominator, 2 times 2 is 4, 4 times 2 is 8. What is the length of the cube that you think best packs the right rectangular prism? Again, because the denominator is a 3, I would use 1/3. Complete the table with the length, width, height, and volume of the right rectangular prism. I'm probably going to convert these to improper fractions to make my multiplication for the volume easier. 6 times 3 is 18, plus 2 makes 20. So 6 2/3 can be rewritten as 20/3. 1 times 3 is 3, plus 1 more makes 4. So I would rewrite this as 4/3. 3 times 3 is 9. 9 plus 1 is 10. So I would rewrite that as 10/3. 20 times 4 is 80. 80 times 10 is 800. For our denominator, we have 3 times 3 makes 9, and 9 times 3 is 27. Complete the table with the length, width, and height of a right rectangular prism with a volume of exactly 48 1/25 cubic units. Okay, well, let's see here. What are some ways that I can get 48? 4 times 12. I can split 12 into 4 and a 3. So I could use a numerator of 4, 4, and 3. 125 is 5 times 25. And 25 can be broken up into 5 and 5. So I could use 3 5s for the denominators. So the first one might say 4/5. And then I have another 4/5. And then 3/5. That appears to work. Let's look at some other possibilities. What if I broke up 48 a different way? 48 is 2 times 24, and 24 can be broken up into 6 times, not 3, 6 times 4. So I could make it say 2/5, 6/5, and 4/5. Let's try that. And that appears to work as well. Let's see what would happen if we put in an incorrect answer. It wouldn't fill it up all the way, or it would overflow. So if you have an incorrect answer, it will not fill it up perfectly. But if your answer is correct, it will fill up your solid with exactly the correct volume. That is the end of lesson 15. Again, if you didn't have access to the digital lesson, you can just take notes in your workbook.